another Science Saturday. I'm Shannon from the Ingersoll Library, and joining me for Science Saturday today is Leslie from the Ingersoll Library, and she's going to help us do some really cool experiments all about rainbows. To start off, we have two books here to show you all about rainbows. This is a first reader book, and it is a level 1. And you can find it in our catalog at www.ocl.net. And it is simply called Rainbows, but it goes all through what a rainbow is, all of the colors, and some basic science that explains how a rainbow is formed. And even some double rainbows.
And this book here is one of our Magic School Bus books, if anyone has watched the Magic School Bus. This one is Magic School Bus Makes a Rainbow. So inside you'll find the class goes along with Miss Frizzle on her adventures on the school bus making rainbows.
Very cool. Good books to get us started. And we have a couple really fun experiments, and they're pretty simple, and you can try them with things you have at home. So we're going to jump into making a walking rainbow. Have you ever heard of that?
A walking rainbow. No, I have not heard of a walking rainbow.
All right, let's do it. Before we get started, what is a rainbow? How's a rainbow formed? A rainbow appears when white light, sunlight, passes through a prism, so water droplets, to refract or bend the light. So light travels slower in water than it does in air because water is more dense than air is. So the sunlight enters the rain droplets, the water droplets in the air, and they refract and split the light into their own separate colors called spectrums. And the light spectrums that we end up seeing in a rainbow are red, orange, yellow, green, blue, and violet. Okay, so to set up the walking rainbow experiment, you need 6 jars or 6 cups. They don't have to be clear, but it's really cool to see all the colors. So we have 6 clear baby food jars here, a plate to put them on, I have a cup of water, a spoon for mixing, and food coloring. So I have red, yellow, and blue, the 3 primary colors of food coloring. And we need 6 pieces of paper towel. But the walking rainbow uses something called capillary action. And I have a book here. So capillary action is the motion of water and liquids going upwards and traveling. And I have a book here called The Magic and Mystery of Trees. And it shows you a capillary action that we see in nature. So tree roots in plants, plant roots, use the capillary action to soak up all the water from the ground and send the water up through the roots to the rest of the plant. So that's an example of capillary action in nature. You can see on this diagram here in this book, it shows you that water travels up the roots. So instead of roots, our capillary action is going to happen through the paper towel. You can see here we have our primary colors, which are yellow, red, and blue. And those are the 3 primary colors that make up other colors. So we have complementary or secondary colors too. So you can see on the wheel here, our blue and our yellow makes green as the complementary. Our yellow and red makes orange. And our red and our blue makes purple. We're going to set up that sort of thing here with the jars. So only 3 of the 6 jars need water. And it doesn't matter how much water. And with every other jar. So we have water, empty, water, empty, water, empty. And the 3 with water in them are going to represent our 3 primary colors. So we're going to make the same sort of thing with the wheel. Very nice. Okay. Okay. So we have mimicked the color wheel here. So how do you think we're going to make our secondary colors in our empty jars? So with any experiment, you can make a prediction or a hypothesis. What do you think is going to happen, and how are you going to design your experiment? So we want to be able to make those complementary colors by mixing these using our paper towels.
Okay.
So we are taking our paper towels. These are the thin individual sheets, and all you have to do is roll them just like that. And we're going to roll all 6 of those. All right, so our 6 paper towels are going to act as the bridges between the colors, and we're going to see the capillary action soaking up the liquids and moving it upwards. So now we have to make bridges between the colors. So I'm going to add to the empty ones, and you're going to do the same thing, Leslie. So you're going to put one from there to there.
Okay.
And do that for all the colors, so all the jars are connected by a paper towel.
See that capillary action starting already right there.
Yeah, so it's already soaking everything up. So, what do you think is going to happen with the empty jars? Hopefully, the colors end up mixing and making those complementary colors, those secondary colors. You can watch them slowly climb up. In this experiment, you can see it starting right away, but for the best results, you're going to set it and forget it. So you're going to set it and leave it for quite a few hours, or even overnight. So our walking rainbow is started. We're going to set it aside and do another experiment.
Okay. So our next experiment, we are going to be looking at chromatography.
What is chromatography?
So chromatography is the science of separating mixtures.
Okay.
Yes.
So are we going to be separating colors?
Yes, I think so.
Okay.
So we're going to be separating all of the individual colors that you find within one color.
For this experiment, you need coffee filters, cups of water, and washable markers. So we have black, brown, green, pink, purple, and orange. And we are going to try and separate the colors and see what they're made up out of. So to set up this experiment, you need to take one single coffee filter, and you can kind of flatten it out a little bit. And you're going to start with one of your colors and just color in a circle, but not directly to the center. I'm going to show you what I mean. You're going to color a ring of color. So a ring of color, one single color per coffee filter. So once you're done that with all of yours, you're going to fold them. So fold it in half, make a crease, and then fold it in half again. And in half again, one more time. So now on your triangle, you should have a white point and then the ring of color. And this end just sits in your water, and your coffee filter will sort of expand and stop it from sinking in the water. And then you can start to see that same sort of capillary action moving upward and dispersing all the colors. So you can see the color is moving upward through the coffee filters and beginning to separate out. So with our black marker there, you can already see some blue. So we use the markers to sort of label the cups so we know which was in each color. We don't end up mixing them up. As you can see, the experiment doesn't take very long. And I can tell there is some chromatography or separating of mixtures going on here.
Definitely, it's very neat.
So when you are done, this has only been about 2 minutes that we've left this one alone. Part of your experiment could be, how long does it take? Does it change? Does the temperature of the water matter? How else could you change this experiment and design your own? So when you are happy with your results, you can carefully take them out. They will be wet and drippy. And put them on a piece of paper or something so you can lay them out nice and flat and see your results. So which one do you think we should check?
Well, let's try the brown.
Okay.
I lost a lot of the color into, but you can see the yellow even in the cup there. We do have one brown one that was done earlier that's already dry. And this is what we have. There's blue and orange.
Great. So the different colors that make up that brown marker. I'm going to try this one here. So this is the black marker, but it looks quite blue to me.
It worked really well.
Looks like tie-dye. Here we are. Yeah, I'm just going to hold this up here.
Yeah.
So there is the black one, the black marker, and I see blues and greens and maybe a purple in there. This is a coffee filter that I did with a black marker earlier, and it is already dry. And you can really see the color mixing and all the colors coming out. Really strong blues, greens, oranges in there, and all of the colors that make up the black one. Very cool. It dries, we'll let them dry completely to really see the colors come out. So if you have some washable markers and some coffee filters at home, give this really simple experiment a try and experiment with some chromatography. Do you know what these remind me of?
What's that?
Like a butterfly craft. To make wings or flowers.
Yes,
If you're doing that
definitely.
craft, you can... There we go.
Love it.
A multi-use experiment. Well, this turned out really good. How do you feel about going on to another experiment?
Let's do it.
Okay, so we are taking a mid-science Saturday snack break.
Yes.
Right?
Love Skittles.
Actually, I think we're going to use our Skittles to make a Skittles Rainbow. So what you need for this experiment is some Skittles. You could try it with M&Ms also and do an experiment that way. A plate and some warm water. That's it.
Simple.
We love simple
We
experiments.
do love simple experiments.
So what you need to do for the Skittles Rainbow,
Try to refrain from eating them.
yes, you can eat the extra after your experiment is done.
Yes.
So you are going to line the bottom of your plate with the Skittles in some sort of a pattern. You could do it 2 orange, 2 green, 2 red. You could do whatever you like, as long as you follow that same pattern. Okay, so our Skittles are arranged in their pattern. We went with doubling up each color, but you could do it however you'd like. And now all you need to do is carefully pour warm water into the center and let it fill up the plate. And now we wait to watch the rainbow start. You can already see the colors coming out of the Skittles and making their own lines. Very cool. It's actually staying in stripes.
That is awesome. Cool.
So what is actually happening? So the colorful coating on the Skittles is made of sugar, and sugar dissolves in water. So that warm water is dissolving that colorful coating and moving them forward into the center to make this beautiful rainbow.
That was really neat. I wasn't sure. I've seen it done, but I've never actually done it.
So that experiment totally worked. You can already see the color changing again, sort of back to a faded white, because it has dissolved that first layer of color. And I'm going to show you. So the part that was in the water is the white, and it is missing all of its color because it dissolved into the bowl. So variations of this experiment, how could you change it? What pattern? You could change it by the patterns that you put it in. You could use M&Ms. You could try mini M&Ms. You could try other things that are colorful and see if they work. Do you think the Skittles would dissolve in cold water as well as they dissolved in the warm water? And what happens if you mix all of those colors? You can try that at home. And with the leftovers, you can do another experiment or have a snack.
All right, well, so far so good. On to our next experiment. What exactly is our next experiment?
So this experiment is a sort of like a milk rainbow. We're going to watch some substances mix or not mix and see these sort of rainbow colors that we can make. So for this experiment, you need a plate, some milk. Milk comes in different percentages of fat. So I have 2% milk here. You could do it with whole milk too. We're going to explain why. You can also try it with skim or 1% also. We have our 3 primary colors of food coloring. And what is that?
Some dish soap.
Dish soap and a Q-tip. So let's turn this strange jumble of materials into a really cool experiment. We're going to bring you nice and close so you can watch. To set up this experiment, we are going to fill our plate with milk.
Is the milk cold, Shannon, or warm?
It is cold milk.
Okay.
Came right out of the fridge. And that is 2% milk. And you can add a couple drops of each color and sort of spread them out. So Leslie, you can add some colors. I'm going to put yellow, red, and blue. That red already looks cool.
Yes. Whoa.
All right, the blue's spreading out. So now we are going to take the Q-tip and dip it in dish soap. This is a Palmolive dish soap. I don't think it really matters, but it has to be a grease-fighting soap. And you're going to touch the soap right to the middle of the milk.
Whoa.
Whoa! So why did the milk and food coloring react like that when I put the dish soap in the middle?
Well, milk is made up of minerals, proteins, and fats. So when the dish soap enters the milk, the fat begins to break up. The soap molecules run around and try to attach to the fat molecules in the milk. Normally, this process would be invisible to you, but the food coloring helps you see it, all the movement taking place.
Very cool.
So this is a variation of the walking rainbow. This is going to be a climbing rainbow. So using the same capillary action to pull the water upward, up through the paper towel, we're going to watch the rainbow climb. So these are all washable markers, and I left a little bit of space at the bottom of my paper towel. And then I have a plate of water. And all you do is dip the bottom of your paper towel and watch your rainbow climb. Still climbing very, very slowly. So to add to your experiment, you could time this and see how long it takes for your rainbow to climb. You could see how far it actually climbs up the paper towel and measure it. You could try it with different kinds of markers or different patterns. That is a super simple climbing rainbow. To check in on our walking rainbow, remember we said at the beginning this one's going to take a little bit of time. It looks the best when you leave it for like 12 hours or overnight. So it hasn't done much. You can see the colored water has moved up the paper towels. Only a little bit. What do you think is going to happen with these? Do you think it'll make it all the way to the top? Do you think it'll make it all the way to the next jar and actually mix our primary colors? We'll have to wait and see. So this has been about 24 hours. So the color has really saturated into the paper towel. And you can see a beautiful walking rainbow. So to look back at our color wheel here, it looks really good. You can see the yellows. Yellow moved to orange, red to purple, to blue, to green, and then back to yellow. So if you notice, all of the jars now have liquid in them. They all have water in them now. So even the jars that were empty. So every other jar was empty when we first set up this experiment. So water really likes when things are stable, and it has evened itself out. So the water from the full jars used that capillary action, so it moved up through the paper towel and into the empty one, where it was picked up by the next paper towel and started to mix colors. So give a walking rainbow a try at home and see how yours turns out. How could you change it? What if you added more jars? Would there be more colors? So design your own walking rainbow experiment and see how it works.
All right, well, that was fun. Lots of science experiments to try out. So everything, like the books that you've seen here and anything that you need to know about the Oxford County Libraries, you can find on our website, ocl.net.
Stay connected with the Oxford County Libraries on social media as well. So we have Facebook, Twitter, Instagram, and YouTube. And our YouTube page has a bunch of really fun programming videos that you can go back and watch. So try some of these experiments at home. Let us know how they turn out, and I hope you had fun on this episode of Science Saturday, playing with rainbows. So until next time, bye!
Bye.